the course. The book problems are not always very nice, okay? Because we're going to be interested in where various lines intersect. All of my questions on any test, they will intersect at really nice points, okay? So if you get some really yucky values, that is an indicator to you that you made a numerical mistake, okay? So the first thing that we're going to be talking about in our beginning section is graphing linear inequalities. Now, it turns out graphing linear inequalities is very much the same as graphing lines. Okay? It's nearly the same as graphing lines, but we get to shade also. If you own colored pencils, it's a great chapter to break them out. Okay? So, I will go through all of the steps of graphing linear inequalities. We're going to start just by graphing single linear inequalities, but then we're going to grow and we are going to start graphing systems of linear inequalities. Okay? So, what I will tell you is the following. What we will do is first graph the line as if there's an equal sign. So we'll just pretend it's a regular old line. However, if it's got a less than or equal to or a greater than or equal to sign, you're going to graph it with a solid line. If, however, it's what we call a strict inequality, when you connect your dots, you'll see that you're going to need to use a dashed line. The reason why is because we're not actually then interested in equality. It's just kind of a boundary point. Okay? Now, our next step that we will do is take a test point. The key thing for a test point is it cannot lie on the line. Okay? I'll go into more detail and write some more here momentarily, but let's wait with an example until we get there. Now, here's another comment that I want to make. Okay? When we do this, you guys, when we graph these lines, I graph them by first finding my intercepts. Yes, you can solve them for y and then have it in y equals mx plus b form and use your y-intercept and your slope. Okay? I claim that's more work than finding your intercepts. Okay? So, don't worry, we'll go through all of these, but you may recall from section, I think it was 1.1, I defined what our intercepts are. Remember, your x-intercept is where your graph crosses your x-axis, in other words, where y is 0, and your y-intercept is where x is 0. If you don't remember that, you're going to be dreaming it because you're going to hear me repeat it so often today. Okay? Now, if you don't want to graph these lines using your intercepts, you need to remember that if you're going to solve your equation for y, the key thing is with an inequality, if you multiply or divide by a negative number, what do you have to do to your inequality sign? You have to switch it. Okay? So, let's start with this guy first. Suppose we want to graph 2x minus 3y is less than or equal to 6. Okay? Yeah, we can solve this for y if we would like to. I'm not going to. I'm going to do my intercepts right from the get-go. Okay? So, if I want to find my x-intercept, recall the way you do it is you set y equal to 0 and solve for x. Why do method because whenever you set something to 0, doesn't it totally nix that term? Yes. So, if I set y equal to 0 and solve for x, remember we're first dealing with this as though we have an equal sign. Aren't I solving 2x equals 6? Right? If y is 0, this term goes bye-bye. So what is x equal to? 3. To find my y-intercept, don't I set x equal to 0 and solve for y? You with me? Well, if I set x equal to 0, that nixes this term. Aren't I solving negative 3y equals 6? So what is y equal to? Negative 2. Okay? If this is funky, don't worry. We're going to be doing this all class period today. All right. So I can graph this line. It goes through, my x-intercept is 3, and my y-intercept of negative 2. Let me ask you a question. Before I play connect the dots, am I going to connect my dots with a solid line or with a dashed line? Solid. The reason why it's a solid line is because I have this equal to. That indicates that we're also interested in the points on the line. Is everybody okay this far with graphing our line? Okay. Now, we are not only interested in the values of x and y that give us this equality, we're also interested in all ordered pairs where 2x minus 3y is less than 6. Okay? This is where taking a test point comes into play. So what we're interested in is all x, y values that lie on this line and either lie above or below the line. So what you're going to do is take a test point that doesn't lie on the line, because that won't give you any information whatsoever. Okay? If when you plug it in, if you get a true statement, you're going to shade on that side of the line. If when you plug your test point in and you get a false statement, guess what you're going to do? Shade on the other side. Now, my very favorite test point to choose whenever possible is 0, 0. Again, that is just because I'm as lazy as can be and I don't want to have to do too much work. Okay? Zeros are nice, except when it talks about your bank account. So, if I take a test point of 0, 0 and plug it in here, do you guys agree that my whole left side of my equation is 0? And don't I get the statement that 0 is less than or equal to 6? If you have a question on how I'm getting any of this, ask. Don't be shy, just yell out. Well, let me ask you this. Is 0 less than or equal to 6? Totally! So, since 0, 0 lives on this side of my line, and when I plugged it in, I got a true statement, I'm going to shade on that side of my line. If this is kind of funny to you, don't worry. We got more. All right. Let's do this guy. What if I want us to graph how about 3x plus 4y is less than negative 2? Again, I am going to use intercepts to graph this guy. To find my x-intercept, don't I set y equal to 0? Yes, I do. If I set y equal to 0, do you all agree that nixes this second term here? Yup. negative 2. So isn't x equal to negative 2/3? Should you freak out because you got a fraction? No, it's all okay. All right, my y-intercept, what I do is I set x equal to 0. Do you all agree if I put in x equals 0, that nixes my first term? So aren't I solving for y is negative 2? So isn't y negative 1/2? If you leave it as negative 2/4, I don't care. I have to reduce my fraction. Because then I will freak out. Y'all with me here? Okay, let's plot those points. X is negative 2/3. That's about right there, don't you think? Y is negative 1/2. That's about right there. Do I connect these dots with a solid line or a dashed line?
Dash.
Dash. Am I done? Nope, gotta take a test point. What do you want to test? 0, 0, me too. So let's test 0, 0. If I plug 0, 0 in here, don't I get 0 is less than negative 2? Is that a true statement? No! All right, you guys, we plugged this point in, and we got a false statement. So we jump to the other side of our line, and we shade it. You guys with me there? I have one more example, and then we're going to grow. Yes? Okay. You take a test point on one side or the other. I'm testing 0, 0, which is right here. Okay? Do you agree? Do you agree if I put 0, 0 in, I get 0 is less than negative 2? Do you agree that that is not true? So, if it's not true, you shade on the other side. If it's false, shade on the opposite side. From whatever test point you pick, which more often than not is 0, 0. Thank you. All right. What if I want you to graph y is less than or equal to negative 1? He's a special case. Now, we're not going to be doing this one, finding x and y intercepts, are we? There is no x in this equation. So remember, your first step is always to graph it as though you have equality. So let's graph y equals negative 1. Tell me, what kind of line am I looking at when I have y equals? What is it? A horizontal line. No, beautiful thinking. Okay? Right? Because isn't y always equal to negative 1 with a horizontal line? Remember, if it's x equals, it's a vertical line. Notice I made a solid line because I have this equality there. You guys with me there? Please do not forget about horizontal and vertical lines. Okay. Well, tell me something, you guys. We don't even really need to deal with the test point here. We're interested also where y is less than negative 1. Is that above the line or below the line? It's below the line, right? Because your y values get more negative. You guys with me? Okay. Now, let's start looking at more than one line at the same time. Okay? Now, my hint to you guys is this. When you are considering a system, shade carefully. Don't shade very dark and all over the place because you're just going to have a royal mess. All right? We're going to start out really chill and just have two inequalities that we're going to graph right now. So suppose I want us to graph this system. 2x minus y is less than or equal to 1, and 3x plus y is less than 6. Now, I mentioned to you this is a good section to break out your colored pencils. I'm going to graph and shade each of these lines in a different color, okay? Just so I know what I'm talking about. So, what I'm going to do is I'll do this first guy in blue. Okay? Look at each of them separately. Don't consider them at the same time yet. Okay? So, if I want to find my x-intercept here, don't I set y equal to 0? Okay? So, aren't I then solving 2x equals 1, or x is a half? Any questions this far? Okay? Now to find my y-intercept, I set x equal to 0. So aren't I solving negative y is 1? So y is negative 1? You guys with me here? You okay? All right, let's graph this guy. So, I have x to be equal to 1/2 right here, and I have y to be negative 1 right here. Am I going to connect my dots with a solid or a dashed line?
Solid.
Solid. Am I done here? No, I need to take a test point. I'm going to test 0, 0, as usual, if I can. Do you agree if I plug 0, 0 in here, I get 0 is less than or equal to 1? Is that a true statement? Yes. So, since that is a true statement, and 0, 0 lives right here, I'm going to shade on that side. See how mellow I was with my shading? Okay, my next line, how about we do him in green? So, let's find our x-intercept. To find my x-intercept, don't I set y equal to 0? So I'm solving 3x equals 6. So what is x equal to? 2. You with me here? Right? You divide both sides by 3? Yeah. All right. Gotta love this next one. Let's find our y-intercept. How do you find your y-intercept?
Set x to 0.
Set x equal to 0. It doesn't get any nicer than that, you guys. Aren't you thrilled? You guys are tough ones to please here. Here's x equals 2. 1, 2, 3, 4, 5, 6. Do I connect these dots with a solid line or a dashed line? Dashed line. Pretend this is a straight line too. Okay. Now what I need to do is I need to determine which side of my line to shade on. So I'm going to take a test point, and I am going to take 0, 0. If I plug 0, 0 in here, do you all agree I get 0 is less than 6? Do you all also agree that that's a true statement? Yeah. So since 0, 0 lives on this side of my line, I shall shade on this side of my line. I am not done. Are there questions this far? Now, when you're solving this histo, what you want to do is find a region that satisfies everybody. So specifically here, I'm asking where did I shade both blue and green? So, did I shade both blue and green up here? No, I only shaded blue right here. Did I shade both blue and green right here? No, I didn't shade anybody there. Did I shade both blue and green here? No, I only shaded green. Will you guys grant me that this region right here is where I've shaded both colors? Okay. Y'all good? Okay, now, ready? Foreshadow. What we're going to be interested in is where our lines cross. And we're going to start playing with that momentarily. Not with my next example, but with the example after that. In other words, I want to know this point right here. Okay? Now, here is something that I'm going to tell you. On my exams, because you'll see this on your third exam and you'll see this on your final, I promise you. Okay? On your exams, number one, I always provide graph paper. Okay? It's on your test. The reason being this. If you graph your lines correctly and use like your calculator to make a straight edge, it will be very obvious where your lines cross. You'll actually just be able to read it off of your graph. Okay? So, but let me make a quick comment. Suppose you're kind of sloppy with the way you do things, or like you're in this situation where your pencil's not very sharp. Aren't I asking where 2x minus y equals 1 and 3x plus y equals 6 intersect? Isn't that what I'm asking? I'm asking for the ordered pair that lives on both of these guys. Do I know how to solve a system of equations like this? One hopes, given the fact that we just covered it pretty darn recently, right? And this one's actually pretty sweet because notice, I can use my addition elimination method and I already have additive inverses. You guys with me? So you could go through and solve it. I'll just solve for the x value, right? You get 5x equals 7, so they meet at 7/5. And then could I get my corresponding y value? Yes. Now, again, mine will always cross it like 4, 3, or something really nice. Okay? All right. Ready for another example? Cool. So then, I have 2 more examples to do today, okay? No, that's not okay. So, 2x plus 3y is less than or equal to 12. 2x plus 3y is greater than negative 6. 3x plus y is greater than 4. And x and y are greater than or equal to 0. Whoa, what a big one, huh? Your enthusiasm doesn't seem to match mine. Okay, now, let me begin by making a comment about this last guy. On your exams, you will always have x and y greater than or equal to 0. Okay? I'll talk about why you're psyched about that, but before I talk about why you're excited about that, let me explain why. No pun intended. All right? The reason that we're always going to restrict ourselves to both x and y greater than or equal to 0 is precisely because the reason why we're learning this stuff is because we're going to want to solve word problems using this. Okay? And when we solve word problems and we define our variables, don't we always define our x's and y's to represent a quantity? Yeah, right? It's always the number of pounds or the number of bags or what have you. Can you have a negative quantity of something? Okay. Yes, you can. You're right. But in order to actually optimize anything in life, are you going to have a negative amount? No. But you are entirely correct. Thank you. So, my point is this. The reason why x and y is always greater than or equal to 0 is because they're going to represent quantities. And the smallest number of, say, pounds of coffee that I can get is going to be 0. Okay? Now, why do I say that you should be excited about this? Well, check it out. Do you guys agree that x is greater than 0 to the right of my y-axis? Do you all also agree that y is greater than 0 above your x-axis? So, where are both x and y greater than or equal to 0? Only in your first quadrant. So, what that last inequality tells you is this. Yo, when all is said and done, once you've gotten your regions here, restrict yourself to your first quadrant. Y'all with me? It's really important. Attendance is so low today, you guys, and these people are just going to be like seriously out of luck on Monday. Alrighty, so are you ready? Let's do it. Let's do this one in green. Well, ready? If I set x equal to 0, okay, if I set x equal to 0, aren't I solving 3y equals 12? So what is y equal to? 4. If I set y equal to 0, what am I solving? 2x equals 12, so what is x equal to? 6. All right, so let's get this line going. All right, so x is 0, y is 4, y is 0, x is 6. Don't I connect my dots with a solid line? Yeah. Let's hope it's straight. Well, there we go. Now, I need to see which side of my line. Oops, I told you I was going to do that in green. There we go. I need to see which side of my line to shade on. So I'm going to take my test point of 0, 0. If I plug in 0, 0, don't I get 0 is less than or equal to 12? Is that true? It sure is. So since 0, 0 lives on this side, I'm going to shade on that side. You guys okay here? Cool. All right. My next line, let's do it in blue. Again, if I set x equal to 0, aren't I solving 3y is negative 6? You with me? So what is y equal to? Negative 2. I've always wondered when I'm going to trip and fall flat on my face in front of my glasses. All right. If I set y equal to 0, aren't I solving 2x is negative 6? So x is negative 3. Am I going to connect these guys with a solid or a dashed line? Dashed. What do I need to do next? Take a test point. How about 0, 0? What an original thought, huh? Well, if I put 0, 0 in this guy, do y'all agree I get 0 is greater than negative 6? And isn't that a true statement? It sure is. You'd rather have no money than be in debt $6. So since 0, 0 lives on this side of my line, I'm going to shade on that side. Will you guys grant me that at this point, I'm bounded between my lines here? All right, we got this one band happening. All righty, one more line to go with this guy. Again, intercepts. If I set x equal to 0, oh, this is sweet. What's y equal to? 4. If I set y equal to 0, aren't I solving 3x equals 4? And therefore, isn't x equal to 4/3? All right, so I've got y is 4. I've been there before. And x is 4/3. That's about right there, don't you think? Yeah. Am I going to connect these with a solid or a dashed line? Dashed line. Next, test point. How about 0, 0 again? If I plug that in, I get 0 is greater than 4. What do you think about that comment? No, 0 is not greater than 4. So am I going to shade on the side of my line where 0, 0 lives? No, I'm going to shade on my other side. Last but not least, remember, we're really only interested in our first quadrant. Do you all agree that the only place where I shaded all 3 colors is right in here? You're going to get cute little regions like that. Now, I'll grant you I shaded all 3 colors down in here. The thing is, remember my last inequality said stay in your first quadrant. You guys with me here? All right. Now, these guys, once you find your feasible region, these guys are your corner points. Okay? In other words, either where 2 of your lines intersect or where the lines intersect your x and y axis. Can you guys tell me what our corner points are here? Yeah. What's this corner point? Well, isn't this my y-intercept of my red line or green line? Yeah, what is that? 0, 4. You guys with me? I know this guy, because isn't this guy my x-intercept of my green line? What was the x-intercept of my green line? 6, 0. And I know this guy, because this is my x-intercept of my red line. And wasn't that 4/3, 0? All right. You with me? I promise you we're not doing this for nothing. We're going to go somewhere with this. Okay? So I have one more example that I want to do. And I'm even going to do it on graph paper. All right. Are you ready? Yeah. This is a really great one. I mean, I know they all are, but x plus y is less than or equal to 9. This is totally the reason why it's so great. X plus 2y is greater than or equal to 10. X is greater than or equal to 4. And y is greater than or equal to 0. Notice I could have put x and y are greater than or equal to 0, but that would be redundant because x already has to be greater than or equal to 4. So this is my system that I want to graph. And not only do I want to graph this system, but I'm going to find the corner points too. And keep this guy in mind because I'm going to come back to him again on Monday. Okay? All righty. So, how about we do our first line in blue? How about? All right. The reason why I think this one is so great is, look, if I set x equal to 0, what's y? 9. If I set y equal to 0, what's x? 9. I'm looking at my top line. So, I have 9. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really dizzy to look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Do you all agree I'm going to connect them with a solid line? Yes. All right. I'll make it as straight as I can, but this, it's not like this pen is very fine pointed. Okay. I need to take a test point. How about 0, 0? If I plug in 0, 0, don't I have the inequality 0 is less than or equal to 9? And I think you'd all agree that that is true. So I'm going to shade below that line. Questions on the blue line? All right. Let's make a green line. Ready? If I set x equal to 0 for my green line, my next line, aren't I solving 2y equals 10 and therefore y is 5? Okay, I'll plot that point. 1, 2, 3, 4, 5. Next, if I set y equal to 0, what is x equal to? 10. You guys all with me on this? Okay. All right. Am I going to connect these dots with a solid line or a dashed line? They're all going to be solid here, which is cool, because then I don't have to remember. All right. I'm going to do my best to draw a straight line, which I can't even do when I have a piece of paper next to it. Pretty sad. Now I'm going to take a test point again of 0, 0. And I get 0 is greater than or equal to 10. What are you going to tell me about that? Oh, no. So, am I going to shade on the side where 0, 0 lives? No. I'm going to shade on the other side. How's this going so far? If you didn't like graphing lines before, at least try to convince yourself that you like it now. Huh? That's my shading. No, great. You got to question me. All right. This line. What line am I graphing? Aren't I graphing the line x equals 4? What kind of line is x equals?
Vertical.
A vertical line. 1, 2, 3, 4. All right. Now look at this, guys. I don't really need to take a test point because aren't I also interested in where x is greater than 4? And don't my numbers increase as I move to the right? So, aren't I interested in this side of my line? You guys with me here? Okay. So, now what I want to know is number 1, where is my bounded region? And number 2, what are my corner points? Well, I claim that my bounded region is right in here. Isn't that where I shaded? It's a triangle too. Isn't that where I shaded all 3 colors? All right, I got some corner points. Now, as I mentioned to you guys before, if you have a pencil and it's sharpened and you drew your line straight, you'll be able to read it straight off of your graph, okay? These are not sharpened at all. So, what I'm going to show you is, if you were sloppy with it, which I always am, or your pencil wasn't sharp, how can you find what your corner points are? Let me show you guys. Do you all agree that these 2 corner points lie on my line x equals 4? Yes? So, aren't my x values for each of those points All right? And isn't this top guy where red meets blue? Well, look at this, you guys. With my blue line, if x is 4, what does y have to be equal to? 4 plus what gives you 9? 5. And I claim we can actually even read this, because 1, 2, 3, 4, 5. What does it look like this one is? 4 what? It sure looks like 4, 3, but isn't this where red meets green? And you all agree, if x is equal to 4 here, I have 4 plus 2y is 10. So 2y is 6, or y is 3. See, there's ways to check yourself. It's all I'm trying to point out. You with me here? All right. Next, isn't this point here that looks like a total rack where green meets blue? Sounds like we're playing like Clue or something, right? You all agree it's where those two lines meet, okay? So, if your thing was a total wreck, what you could do is solve that system of equations. Couldn't you? Yes, you can. And I claim you're going to get x is 8 and y is 1. Now, if I drew this halfway decently, it would also appear there. Are you guys all with me on this? Okay, cool. One more quick comment, and then I'll let you guys go. Yes?
If you do ask what are the boundary regions on the test with?
Yes. Yeah, I will ask you what your feasible region is, and you can even just, if your graph is kind of yucky, you can kind of make an arrow and say, this region. Okay? Yeah. Now, one other comment, you guys. We're going to be using this next week on Monday. Okay? Now, I'll explain to you why we're doing this next week. But what I want to say to you guys is the following. We're also going to be doing word problems in Chapter 3, and they're very similar to the word problems that you set up and solved in Chapter 2. So I want you guys to review that this weekend. Okay? On Monday, I am going to finish talking about Chapter 3. Next week on Wednesday, I'm going to review, because again, next week on Friday is your test.